we start from the mains connection. We have a plug each rack, a general one-phase, single-phase connection, neutral and phase, going to the splitter, internal splitter, okay? So one neutral, phase, 1, 2, 3, together connected, and they go to the power distribution board. This is the same for the second rack, same. So you will have these two block as main connection. You will come with single phase 1 connection, rack 2, single phase for the connection, the rack 1. Okay, this regarding the main connection.
It goes there.
Please consider that the mains connection from the unbalanced dummy load is already wired inside. So you will have the plug. Okay? So for you, from the 50 kilowatt transmitter to your power distribution, you have only 2 cables. One cable for the rack 1, one cable for the rack 2, both single phase. Okay? Very simple. Then, regarding the radio frequency, double exciter, the 2 exciter are here. This is the block of the switching between the exciter, all controlled from the VCU, okay? Here is the coaxial relay, here the dummy load. You can operate the second exciter still on, in the time that you are on air with the other exciter, okay? So it's 4-port coaxial relay. You can operate both exciters at the same time. One on load, one in service, okay? The power of this, so the power of the switching system of exciter will be splitted here in this splitter. So this splitter receives the output of the exciter changeover and divided in 2 parts. One part for the rack 1. Here is the power splitter for the amplifier.
All right, so splitter.
Okay.
One, the input, one output.
Going to
second
the
output.
Amplifier splitter 10 ways. We can see from the other side. Then distribute the half of the power to the 10 amplifier, input amplifier, okay? The other half is going on the second rack, and you can see from this side how is the splitter. Splitter have 1 input, main input, and 10 output. Each of these is going to the input of the amplifier. Simple, input of each amplifier is coming from here, okay? This is the RF input. Then we are going to see the RF output, the combining. This is the combiner. This is the combiner. The output of each amplifier is connected to the input of each amplifier, of the combiner, sorry. Then you have 10 unbalanced dummy load are here connected. This you will receive the rack already wired. You don't have to change nothing, you see? Already connected. So 10 inputs coming from the 10 amplifier, 10 unbalanced going to the 2 block dummy load, okay? This is the RF circuit, nothing more. At the output of the combiner in size 318 inch, we have a measurement directional coupler. Here we take the power measurement, okay? Same block in the rack 2, in the rack 1. This closes the rack part of the radio frequency. Then we are going to the hybrid.
This is the combiner.
Okay. Then we are going to the hybrid
to
coupler.
the hybrid, okay.
Hybrid, 1 port rack 2, 1 port rack 1, in 318. Then to the other part, output, general output to the antenna with the directional coupler, measurement directional coupler, and the other part, unbalance of the 3 dB coupling system, rigid line wiring, external dummy load. This closes the circuit of the radio frequency, okay? So double exciter, split into 2, each rack, one of the two RF, split to 10, combiner, each rack 10 to 1, and final combiner, power combiner, 3 dB input.
Okay, so that's the combiner with all the inputs coming from every single module, the RF out, combines them and goes into the hybrid combiner. Down here are the unbalanced dummy load connections, and from the splitters, this one, we go to the RF in of each module. And the 4-port relay, which goes into, or rather is connected to the two exciters here, so double exciter. So these are the main connections, all the connections actually, electrical and RF, of all the modules installed in the 2 racks for this 50 kilowatt transmitter.